Mathematics Advanced Subsidiary Level, Paper 2, 2023, Part 5. Question number 5a. Find the exact coordinates of the stationary point of the curve with equation y equals 5x over ln x. Where will you find it in the y equals mx plus c mathematics textbook? You will find it in chapter 11, and that will be derivatives of natural log functions. But that the name of that chapter will be further differentiation. Okay, I'll give you now specific pages. Now, let's start. I'm going to first write it. So, I'm going to follow the quotient rule. And the quotient rule, I'll show you also in a sheet where you can find it, in the formula sheet. But in the textbook, it will be on page 516. Okay. But I think let's go to the formula sheet, because sometimes if it's so straight, it's easy. It's very simple on the formula sheet, that sometimes you don't get everything which you're looking for, the specific things. And it is good always to memorize the formulas. Okay, so this differentiation, and there is the quotient. Did you see this? That's the quotient. So what are you going to do is you're going to write, look, this is the denominator. So I write the denominator, then I differentiate the numerator. Then I subtract, then I write the numerator and I differentiate the denominator. And then I square the denominator. So that would have helped you very 100% in this question. But let's go back to the question and let's do it. Okay. So I'm going to say dy over dx. Okay, I write the denominator, so it's ln x, and I differentiate the numerator. I'm writing it just out for you now. And then I subtract, I write the numerator, and then I differentiate the denominator. Just want to make that ln x. And then the line there, and then I take the denominator and I square it. And that's what I do. So let's just do this. So I'm just going to say it's ln x, and this is just going to be 5 minus 5x. And now again, you can look for that rule. I forgot to tell you also the page, but this is it's just 1 over x. And I think we can also find it in the formula sheet. I have to take you there to show you that it's always good to look at the summaries also. Do you see? There it is. Okay. So let's just go back at the end of the chapters to memorize that summary pages. I also make nice posters of it, which you will maybe see in the classrooms. I also forgot to tell you where in the textbook, what example will specifically help you. So it will be page 485, and that will be example 16, plus page 486. I think that example 17 will also help you. So if you struggle, you can first work out the examples. Let's go back. Now I'm just going to simplify. Okay, so I forgot. And then I'm just going to take the denominator and I'm just going to say ln x squared. Okay, now for stationary points, dy over dx, okay, the y didn't come out, must be equal to 0. Okay, so in this place, I'm going to put a 0. Doesn't matter where. You can put it in the beginning or you can put it at the end. So I'm going to say y is equal, 0 is equal to 5 ln x. I just put the 5 in front. And now look what happens. Okay, it's 5x over 1. So can you see that the x is cancelling out? So I can actually already cancel that x out. So it's just minus 5 over ln x squared. Now put this over 1. And now what I'm going to do is I'm going to cross multiply. Okay, because I have one term equals one term. So I'm going to have 5 ln x minus 5, and 0 times this will just be equal to 0. So I'm going to have 5 ln x is equal to 5. And now, then I'm just going to divide 5, and I'm going to divide 5, and I will find that ln x is equal to 1. Then don't forget that ln, the base is e. So I go from log or ln form to exponential form. So it will be e, I swap that 2 to the power 1 will be equal to x. And that's my value of x. Now, they said, go back to the question, find the exact coordinates. Now, the word exacts means don't go to decimals. Leave it as e. Okay, otherwise you will make a mistake. You will not get your marks. So now I substitute x in original equation. Okay, and let's just do that. So basically, I just go and in the original equation, and don't forget that this is my original equation. There it is. Okay, so I'm just going to say y is equal to 5x over, okay, ln x, okay, this is the original equation. I first wrote it down. So y is equal to 5e over ln, and in the place of x, e. Did you see that? But now don't forget that the base of ln is always e. And if I e, what will that become? 1. So I will have 5e over 1, and that will be y is equal to 5e. And remember, they want it exact. Don't use your calculator. So therefore, the coordinate of the stationary point will be, what's the x value? E. What is the y value? 5e. And that's how I will do number A. Okay, let's go to the exam report, number 5A. It was moderately answered. Many candidates could apply the quotient rule correctly. It was regularly seen that the terms in the numerator were interchanged, or that the law was used wrongly with a plus between the terms in the numerator instead of a minus. Okay. Many candidates struggle to solve the derivative equal to 0 correctly after an initial correct differentiation, which is sad. Once again, the exact solution were asked, and candidates lost marks when their final answer were given in decimals. So exact, leave it. It's almost like without a calculator. Many candidates gave the final solution as that and not realized that ln e is 1. So remember that base of ln is e, and that's why it becomes 1. It was noted that the entire candidates tried to use the product rule instead of the quotient rule. Centers. Okay, some centers. The candidates needed to deal with the derivatives. This provided most candidates with difficulty. They did not realize that they had to use the chain rule to differentiation. Okay, I think that would have been a more difficult way. Then if I look at this, and a common wrong derivative seen is if they did this instead of the correct there. Okay, the teacher's advised to teach both rules and not to just keep to one. Okay, Now, as I said, they gave you for that step. If I go back, so they gave you for this step. And then if you come to that equal to 0, which we did there, okay, for another one. So actually 2 for that quotient rule. And then if you're there, and then if you're for 1 and 1 for that. Okay, for the x and the y. So if I go back to the question paper, can I just show you the marks there? So, okay. So basically what I said is if you use the quotient rule, okay, so they would have gave you 2 and then coming to this and then 1, 1 for just that last one for the x value and then also for the y value. But rather write it in coordinate form at the end. Let's go to number B. Let's just make it a bit bigger. Okay. Show that, and now I see I'm at integration, okay, and they ask me that I must arrive at that answer. Don't use the answer. You must, at the end, you must not start with that answer. You must end with that answer, showing all necessary working. Now, where will I find this? I will find this in chapter 12, and that will be further integration. And that will be on page 5 to 6. Okay, now let's start. So we just start with the left-hand side. It's almost like your proof. It's equal to the right-hand side. So if it's my integration sign. I just want to change my color to blue. So it's 1 over 6 pi. And as soon as you see 1 over 6 pi or 1 over 3 pi, then you must always remember I'm going to go to the special angles. I'm not going to use the calculator or to find that values. So, and then it's going to be 6 sin square x plus tan square 2x, and then it's going to be dx. So that is going to be my left-hand side. And I must just prove it's equal to the right-hand side. Now, you can go to the formula sheet, but the formula sheet is just showing the very, very simple ones. Okay, so in this case, in the chapter, in the y equals, chapter 12, y equals mx plus c mathematics textbook, I really helped you with showing you the sin square x as well as the tan square x. And where would you find that? You will find that on page 5, 4, in the summary. You can go to there, to the summary, to page 545, or you can go there to page 5 to 6, and then also page 5 to 7. Go there. There you will find it. And that's why you don't just use the formula sheet. If you study, don't just use my summary and my textbook. I think the best is, well, if you create your own summary, that you put everything in and then memorize it so that the picture is in your mind. Okay, so basically, I didn't integrate. I just get it in another form, and that's what you will find on that pages. So basically, what I'm saying there to you is I'm leaving the 6 and I'm just going to put this in another form. And if I look there in the textbook, it's a half 1 minus cos 2x. Plus, and what is tan? I think it's on the top of the page there. And that will be, and remember it's tan 2, so it will be sec square 2x minus 1 dx. So just take note, I did not integrate already. So I was just using the double angle identities before I went into integration. Okay, so I can now go and I can still keep this. I'm just going to simplify a little bit. It's always good to get it a little bit more simplified. So this 6 times a half, that will just be 3, 1 minus cos 2x, okay? And then it was plus sec squared 2x minus 1. And don't forget that it was integrating 2x. Okay, so now I have the identities in, and now I can go into the integration. Okay, so in this case, just take note that this is actually 3 minus 3 cos 2x, if I wanted to put the extra step, but just you can keep it in mind. So if I integrate 3, it will be 3x minus, now I'm going to integrate this. It's 3 times a half or 3 over 2, doesn't matter. And then cos 2x goes to sin 2x. Now I'm going to integrate sec squared 2x, and that will go to tan 2x over 2. So I multiply also that with a half. And then the negative 1 just become negative x. And remember, what is your limits, your boundaries? So it's 1 over 6 pi, and it's 0. Okay, so I integrate it. Now, I think before I substitute, I'm going to just simplify it. So 3x minus x, that will be 2x. So minus, I didn't substitute yet. I'm just simplify that little one there. So 2x minus plus a half tan 2x. Okay. And it's 1 over 6 pi, and it's 0. Okay, now I'm going to substitute. So if I substitute now, I'm going to start by saying 2, and I substitute 1 over 6 pi minus 3 over 2 sin 2 1 over 6 pi plus a half tan 2 1 over 6 pi. Okay, so I did the first one. So minus, and now don't just assume that everything will be 0. It's best to just test it. So 2, 0 minus 3 over 2 sin 2, 0 plus a half tan 2, 0. Okay, and that will be equal. Okay, now I can start simplifying. So this is 2 over 6, so it will be 1 over 3 pi minus 3 over 2. Now this is sin. I will now substitute 1 over 3 pi, exactly the same because it's 2 over 6, plus a half tan 1 over 3 pi minus, and then it's just that 0 minus 0 minus 0. So all that will, because it's multiply 0, you see, so I think that was even a plus, but that will become 0. Okay, so now I go further. Now here is not a ratio, so it's 1 over 3 pi, not sin or cos or tan. But now I go to my special angles. I forgot. I could have told you a page. You could have go to page 528. You could have go to example 15. And you could have go to page 529, example 16. That would have helped. Okay, so you can always look at the video, go to that examples, and then try to do it again. Okay, but for now, I'm at my special triangles, my equilateral triangle that I'm always working with. And then I'm just going to, this was 2, this was 1, and this is square root 3. And because it's 60, it's pi over 3, and this is pi over 6. Okay, so 2. Now, if it's sin, I'm a substitute. So sin, pi over 3, sin, okay, remember your saw. ka, to, a. So remember that sin is opposite over hypotenuse. So minus 3 over 2. So it's going to be square root 3 over 2 plus a half. Now tan, what is tan? It's opposite over adjacent. So it's going to be square root 3 over 1. And then it's that minus 0. I can now throw it away in the next step. Okay. So don't forget that this one is having a pi. Okay, so leave him. But this, I'm going to try to simplify this. And remember, keep it exact. I'm trying to show something. So this is going to be minus 3 square root 3 over 4 plus square root 3 over 2. And then I'm going to multiply with 2 there, multiply with 2. So it's going to be 1 over 3 pi minus 3 square root 3 plus 2 square root 3, and that will all be over 4. Okay, so if I simplify that further, it's going to be 1 over 3 pi, or pi over 3, which is the same, minus square root 3 over 4. So let's just go there. Pi, 1/3 pi minus square root 3 over 4. And then you could have just say, end with left-hand side equals right-hand side, or you could have end just with the statement. It seems to me in this videos, I forgot to take you to, so now I have to take you to both, okay? So let's just go to the report. Let's first do this one. So let's just go there, and then we'll just put the other one in. So if I look here, I'm at question number 5. Okay. I just want to see if it starts on the previous page. Question 5. Yes. So let's just go to number B. I just want to make it bigger. Poorly answered. Most candidates did not realize that they need to rewrite this to double angles and this to this before it could be integrated. So this was very important. That's why I said make your own summary. You will not find it in the formula sheet. Some candidates who realized that they had to use the given identities failed to replace the A with an X as required by the question. It should not be noted that candidates should show that they dealt with both boundaries. If the application of 0 is 0, candidates could just say minus 0. So you must show it and show that the bottom boundary was applied as well. Okay, so you cannot assume it's 0 and not right. So you don't have to say minus 0, 0, 0, but just one time minus 0. Okay, if you see that all will become 0. So there you see that I was placing it in. There I put this. Then I was doing the integration. Did you see there? Then I was starting, and there you see, rather write it fully out like they did it there. And then I establish the answer. Okay, and this was, wow, this was quite a lot of, but let me take you to the question paper again, and let me show you where that they gave you the marks. Okay, so if I look, they would have been, for that, because you substitute 2 in there. So for this, to come to both that one actually and that one, they gave you a mark. And then for the integration, if that is 100% correctly. And then if you do the substitution, which is there. And then the final one is if you establish. Okay, and that was your final answer. All these videos refer to the y equals mx+c textbooks, the #1 mathematics textbook used in Namibian schools. For more information on these textbooks, visit the Straight Line Publishing website. All y equals mx+c to success textbooks are available in the NEED catalogue of the Ministry of Education. Schools can order these using their yearly budget for textbooks, with the process typically starting mid-year. Make sure your learners have a copy of the Y equals mx+c mathematics textbook used by the top schools in Namibia in front of them in 2025. A final point. If you are in the position, I want to encourage you to buy your own personal copy of the Y equals mx+c mathematics textbook. These textbooks are available at the following bookshops. Remember, success in mathematics comes from hard work, perseverance, and the courage to face challenges head on. Good luck with your final 2024 examination.